A good day to everyone. I am Tinagaran Ravishankar, 2180060. Would like to present my thesis entitled Numerical Simulation of Gypsum Board Subjected to Impact Loading. Introduction. Gypsum board, a lightweight, fire-resistant and good sound isolating board, is commonly used in building and design projects. Gypsum board is subject to impact during manufacture, maintenance and use. Mishaps in the workplace as well as caused by transportation disasters or human mistakes may result in an accidental effect load. A best numerical analytic approach, on the other hand, is just required to complement the rack of experimental findings. What are the objectives? First, to determine the suitable material models to simulate gypsum board modeling. To investigate the low velocity impact on gypsum board of various thickness via impact test simulation. Third, to validate the output of simulation against the previous study. The problem statements. The main problem is to determine the material model that need to be used to define the gypsum board. Numerical simulation of impact loading is difficult due to the difficulty of modeling the dynamic contact between two bodies, material under strain and load rates. There are a variety of methods to study how an impact load will affect a gypsum board, some of which are unrealistic or costly, but numerical technique is very cost-effective method, but knowledge on software is very crucial. Now let's jump into meteorology. Selection of element type. Different type of material behavior has been studied in order to better understand the impact resistance of gypsum board. Second, defining the material properties. Many forms of material behavior has been investigated. Next, defining the shell section. Shells element can be used in finite element analysis to get good results. Third, interaction of elements. Contacting and creating a correct interaction between the components is an important part of any sort of finite element analysis. Next, defining the velocity of ball. In LS-DYNA, the variable initial velocity and initial velocity generation can be used. Surface to surface. The most common method to define contact between elements is automatic surface to surface command. Termination. The duration of simulation is known as termination time. Defining the output. Binary D3 plot has been used to define this simulation. Now, look into the data and analysis. Graph energy versus time. Met 24 piecewise linear plasticity. From the figure, it can be observed that 12.5 mm firestop absorb energy of 8.67 joule. However, 16 mm and 19 mm 60 mm firestop and 19 mm impact stop absorb energy of 8.84 joule and 9.53 joule respectively. From the graph of 5 meter per second of impact simulation, it can be observed that 12.5 mm firestop absorb energy of 2.52 joule. The 16 mm firestop absorb 3.12 joule. However, the 19 mm impact stop absorb 3.3 joule. Through modeling, several thickness of gypsum board were exposed to 7 meter per second impact stress. The 12.5 mm firestop absorbed 0.1 joule of energy. The greatest energy absorbed by 16 mm firestop and 19 mm impact stop, which was 0.11 joule. Now let's see energy versus time graph for MET 153 concrete damage model release free. From the figure, it can observe that 12.5 mm firestop absorb energy of 5.66 joule. However, 16 mm firestop and 19 mm impact stop absorb energy of 6 joule and 6.97 joule respectively. From the graph 5 meter per second of impact simulation, 12.5 mm firestop and 16 mm firestop gypsum board absorb 0.11 joule and 19 mm impact stop absorb 0.148 joule. Several thickness of gypsum board was subject to 7 meter per second impact load using modeling. 12.5 mm firestop absorbed maximum of 0.1 joule of energy. 16 mm fire stop, absorb 0.118 joule of energy. 19 mm impact stop, absorb 0.129 joule of energy. In conclusion, impact stop 19 mm has a higher impact resistance than fire stop 16 mm and 12.5 mm. This is because it is thicker than both fire stop. The impact resistance of fire stop 16 mm is moderate since the thickness is more than fire stop 12.5 mm. When fire stop 16 mm is subjected to all three velocities of 2, 5 and 7 meter per second, a hole is appear. Since fire stop 12.5 mm is the thinnest, the impact resistance is severe. All three velocities 2, 5 and 7 punctured the model and left a big hole. That's all. Thank you.